Hey now, welcome to another episode of Code Katas. Let's go ahead and get started. Let's go ahead and get into our folder. Then let's go over to codewars.com. If you don't know, Code Katas are little coding challenges. They rank from easiest at 8Q to hardest at 1Q. The way we like to do is we sort them by most completed. Then we work our way down the list. Let's see which one we're on. Growth of population, I think, is it. So let's see what it wants from us. It says, in a small town, the population is 1,000. It is P0, but here they're saying it's 1,000 at the beginning of a year. The population regularly increases by 2% per year, and moreover, 50 new inhabitants per year come to live in the town. How many years does the town need to see its population greater or equal to P? Right here, it's 1,200 inhabitants. So, at the end of the first year, 1,000 plus 1,000 times the 2% plus the 50 inhabitants that come. So, at the end of the first year, we're at 1070. Not there yet, so we do it again. We take 1070 plus 1070 times the 2%. Plus 50. Then we're at 1,141. Still not there. We're looking for this 1,200. So then we do it again. 1,141 plus 1,141 times the 2% plus 50. We're at 1,213. So we've made it. So that took 3 years to do. So we return 3. Okay. So what we need to do, let's go ahead and bring it down locally. Seed it into our Katas folder. Growth of a population. Put in our title. Let's bring in our function. And let's bring in our test. So the way this is going to work, you can see the arguments that were given. Let's change these to console logs. That's not what we want at all. Console.log. And let's start up Quokka. So we're getting undefined return. That's good. If you look at the arguments we're getting our initial population, the percent that it's going to grow by, the people that come in our example problem, it was 50. Here it will be this number, or will be this number. Yeah, our third argument. And then the last one is the population, the final population that we're looking for. So we're gonna have to sum. We're gonna have to have a place to store our population. So let's say. So let's go ahead and say let's sum, and we'll initially set this to our initial population, and Then we also want to store a place to increment the years, how many years it's going to take, and that's what we'll ultimately return in the end. So we'll say I equals 0. And then, so we're going to increment our sum, and we're going to check it against this final population. So what we want to do is we want to say while, we'll use a while loop, and we'll say while sum is less than the final population that we want, which is p. Then we want sum. We want to increment sum, so we're going to say sum plus equals, and we're going to do our math, and we're going to say sum times. We want to times it by the percentage, so we'll say times sum. Oh, we want to divide it by 100 though. So we'll say percent. So we're not doing floats. Percent 100. And then we want to add the amount of people that come in at the end of the year. So we'll say plus, right? And then we need to increment I also to keep track of our year. So we'll say I plus plus. Cool. So our sum here is the initial population. While it is less than the population that we're looking for, we're going to do our calculations of the people coming in, and we're going to increment the year. And at the end of all of that, what we need to do is return our year, or the increment, the years. If you look and see, we got 15, 10, 94. So that solves it. Cool. So let's go ahead and throw it into Code Wars. See if it likes our answer. Test should work. Let's attempt. Nice. Very cool. Okay, so let's go ahead and submit and check out everybody else's answer. I'm listening to hurricane updates. We're in Houston right now, so Laura's coming for us. Or it looks like it's mainly going to hit Louisiana, but we're going to get some. So let's check out everybody else's answers. Population is less than our final, then we're going to increment. PO equals PO times 1 plus percent. Cool. All right, let's do another one. Remove first and last character. Initially sounds easy. We'll see what they ask us to do. It's pretty straightforward. Your goal is to create a function that removes the first and last character of a string. You're given one parameter, the original string. You don't have to worry about strings with less than 2 characters, so that's cool. So there's a few different ways that we can do this. I know we could do it with the for loop. We could do it with a slice. We could just return Okay, so let's go ahead. We'll do a couple different solutions, or at least attempt them. Let's bring it down locally. Okay, let's bring in our title. Let's train again. Let's grab our function. And let's bring in our test. Change these to console logs. And let's get Quokka started. Okay, so what we want to do is let's use a slice. Now I always have to look up the slice index. I know we can start it at 0 and then end it at a negative number, and that should... Does it return? Let's see, does it return our characters? Let's see what it does. Let's look it up. So the slice method returns a shallow copy of a portion of an array into a new array object. So we have our array here. If we slice at 2, the expected output. Okay. So I think if we started at, let's see if we return. Oh, it wants the, okay. Okay, no, that's right. So we could say, let's see if this works. This might not work. We'll start it at 0, and we'll end it at -1. Does that do it? We need to start it at 1. That does it. So that solves it right there. We could also do it with a loop where we could push or have us build up a string. Okay, so we'll go ahead and can we do something like this? Let's see. Do we say return string at 0? So that'll take. Oh no, we we want to remove. Oh, okay. We want to return the string with the first and last characters removed, so that wouldn't work. Cool. So this first answer is good. I think we could do it with a for loop. Let's just try it real quick. Let's say for, and we're gonna need a place to build up our string. So we'll say let new string, and then we'll say let I equal 0. Then I++. So we'll say if, and let's go ahead and say let letter let letter equals string at index. So if letter so actually we could say if not string at 0 and string and not string. I have no idea if this is gonna work. At string dot length -1. New string plus equals letter. Is this gonna work? I don't think so. We'll see. Return new string. No. Something here is not working. I guess that's testing, so that's not really saying to avoid those. So if we could say how do we do that? Oh, we could say if index, okay, so we could say if index is not equal to 0, or if index is not equal to string dot length -1, something's going on here. What's going on? Why is this code not running? Okay, what about just this? We're messing. Oh, our for loop's not closed correctly. That might help. Okay, and then but we need to. What did we? So that took out that, and then we need to say or if index is not equal to string dot length string dot length -1. Did that do it? No. -2. It's not working at all. How would we do that? It'd be string.length minus 1, right? I mean, let's say if we just said like index 4. Does that remove anything? So maybe we need to do a separate if. Is that what's going on? So if we said, also said if index is not equal to string dot length new string plus equals letter. Whoa! So now we're pushing them all twice, so that definitely doesn't work. Okay. We could go, we could cheat. We could say, what did we say, dot pop? Is that what? Oh, we'd have to pop it off an array. Pops an array method. Oh well, we spent way too much time trying to do that. We're just gonna go with our slice method for now. Okay, let's put it in. Let's test it out. Should have got out when we were ahead. Okay, let's attempt it. Nice. Let's submit it. Let's see what other people did. Cool. Slice. Everybody's doing slices. Split it, shift it, popped it, joined it. That's cool. Not as performant though, because you're looping it. You're having to iterate over the string 4 times. Replace, they're doing regex. Length, this is the part we cut. They're using a slice, they just did it in a weird way. Cool. Alright, let's do a couple more. 2 down. String.repeat. We write a function called repeat string, which repeats the given string exactly count times. So we're given the number of times it should repeat, and we're given the string that needs to repeat. So that's easy enough. Okay, let's bring it down locally. Bring in our title. Let's bring in our function. Bring in our test. And of course we need to change these to console.logs. Let's open up Quokka. Quokka. Close that up, and then let's figure out what we need to do. So I think it's going to be easy enough. We just take our string, and there is a string method, our function called repeat. I think we can just call it on the string, and we pass in how many times we want it to repeat, which would be n. This syntax might not be right. We might have to look this up, but I'm just going to go ahead and attempt it. Return s.repeat, and we repeat it n amount of times, and that does it for us right there. Super easy. And of course, you could turn it into a real one-liner. And we could also do it with a for loop and build up a string. Let's show that, I guess. Go ahead and just copy this. So we could say let repeat string equal an empty string. That's where we'll build up our string. We'll loop. We'll let I equal 0. While I is less than the number of times we want it repeated, less than or equal to n, then we want to I plus plus. We want to increment I, then we'll say repeat string plus equals s, which is our string. And if we return repeat string, we get it. So that's it with the for loop. Cool. So I think the way we'll do it is with the repeat though. Let's test it. Nice attempt. Very cool. And let's submit. All right, still not done yet. This thing takes forever. Repeat, for loop, repeat, put it on the prototype. They built their own repeat function. Huh. Interesting. Cool. Here they're using recursion. That's cool. Alright. Let's do one more. I'm having fun. Find the smallest integer in an array. This is going to be extremely easy. Let's go ahead and bring it down. .js. turn it into a slug. I'm pretty sure you can grab this slug from somewhere in the URL. I'm about to look. Can't we grab the slug somewhere up here? No, just gives us the ID. Huh. Interesting. Okay, so let's train. Is the slug up here? Nope. Okay. Let's grab our function. Whoa, this is funky. We forgot our title, that's okay. Let's put our function in. These tests are weird. Huh. So they're just calling the class. So I guess we need that. Let's bring our test in. Okay, we get what it should return. Don't need that. I hate when they do this for questions like this. Yeah, it should return the smallest integer. We get it. I guess it's for the test suite that they're using, possibly. They need to do that. Let's console.log quokka. Let's see what we're getting here. Undefined. So that's cool. So what we're gonna do, if we log our args, it should be the array, right? Okay, so we get our array. So what we're gonna do is we're gonna say we're gonna return arg. We're gonna take our argument, our array, args.sort. Our sort will take in a function that a and b for arrow, and I think it's a minus b. And then we'll sort it, and we'll return that'll sort the array from lowest to highest, and then we'll return the first number like that. See, that does it. 8, 12, 56, 0, 1. Cool. Super simple. Let's throw it into Code Wars. See if it likes it. Tests. Nice. Attempt. Nice. Submit. Math.min, they spread out the arguments, found the minimum. Math.min.apply. They did the sort, it's what we did. Cool. Alright, let's do one more if it's not too crazy. Oh my god. This one's annoying. Welcome. In this kata, you're required to, given a string, replace every letter with its position in the alphabet. If anything in the text isn't a letter, ignore it and don't return it. Okay. So I'm thinking what we could do is we could have two arrays. One with our alphabet, one with our, we could do an object, I guess, and then one with 1 through 26. There's 26 letters in the English alphabet. We'll find the index of the letter in our alphabet array. We'll get the letter in our string. We'll find its index in our alphabet array, and we'll return. Oh. Well, I guess we don't need an array with the number of letters. We could just use an array with the alphabet. We return the index of the letter that's in the string. We could push it to an array. It's going to get tricky. It says if anything in the text isn't a letter, ignore it and don't return it. So we'll have to figure out that logic. Okay, I think we could do this. We're going to need to make the string 2 lowercase. Okay, cool. Let's do it. It's seeming easy in my head. Hopefully it works out that way. Let's go ahead and train. Grab our function. And then let's grab our test. ToTest. Change these to console logs. Start up Quokka. And then we'll go ahead and bring these down so we can see our output. So right now we're returning our text. Let's just get undefined returns. You see that? That's cool. So what we need is an array. Let's say alphabet, and that will equal an array. And inside our array we'll have A, almost there. Oh, and do each of these need to be strings? They all need to be strings, don't they? I believe so. This is annoying. I'm sure there's a better way to do this, but whatever. We have R twice, QR. This will be S, T, U, V, W, X, Y, and finally Z. Cool. And we could break our array like in the middle somewhere and just let's save it, see how it formats it. Okay, we need to start up Quokka again. So we have our alphabet here. So now if we say let's say if we log alphabet dot index of, and then we put a 0. Cool. And what we want is we want our text right here. We'll say text equals text dot to lowercase. So we'll go ahead and lowercase our whole string so we don't have to worry about any uppercase letters. Then we need a place to store our new string. So that will be here. We'll say let position string, because we're finding the position of the letter in the alphabet. It's the way my brain went, is an empty string. And we'll say, then we'll loop over our string. We'll let I equals 0 while I is less than string, or what do they call it, text dot length, then I plus plus we'll say let position string plus equal we're gonna, because you see how they each have a space after each letter, so we need to add in that space as well. So we'll say we'll use backticks, and we'll say alphabet dot index of, and that will be our current letter that we're looking at. So that will be text at index. And then we also need to have our space like that. No? Did we not spell something right? Position string? Right? Why is position string grayed out? Let's return position string. Oh, I'm seeing some negative numbers. Let's just log one of these so we don't get so many numbers. What are we doing wrong? Let's log text at index. Oh, it's not accounting. Oh, okay. I forgot. If it's a space or like a comma or something, we need to ignore it. That's what our negative. That's where we're getting those negative numbers. So what we want to do, and what we could do is we could filter Can't we say, let's let our text equal, and then we'll say dot replace, We want to use regex. Replace anything. Let's Google. Replace anything not a letter. Regex. So we just need to do A to Z. Cool. So we'll say, what are we doing? Replace A to Z, and that will be global. And then we'll replace it with a blank space. This needs to be a dot and not a comma, though. Then let's go ahead and log text and see what we're getting. Log text. We're still getting our... That didn't remove anything. Oh, with a blank space like that? What is going on? Oh, we need to put it in brackets. Oops. Like that. No? Oh, and not with the spirit. There we go. So that's going to solve our kata. That does it. So we have an array with our entire alphabet. We're taking our input, our text, we're lowercasing it so we don't have to worry about capital letters. We're replacing anything that's not a letter with an empty space. We're gonna loop through that text, and we're pushing to we're building up a string right here with the indexes of that letter inside of our alphabet array. What we need to do though is, since we're adding a space here for our string, we need to slice off the end of the string. So what we need to do, can we just slice, can we just do -1? Will that do it? Remove last character of string, and we'll do that. We want it in JavaScript. 2 methods. Okay. Slice 0, -1. Okay, so that'll remove the last character. Okay. Cool. So we'll return this dot slice, and we'll throw in 0 and -1. That'll remove that last space that we're putting in there. Cool. Let's get rid of this log here. Cool, dude. So let's go ahead and throw that into Code Wars and see what happens. Hopefully it turns out well. Chunk it in. Let's test it. Cool. Oh, we're getting one lower every time. Why? Oh. Do we need to start our index at 1? Okay, why are we getting... Okay, let's think about this. So... Oh, no. Yeah. What's going on here? I mean, we could go +1 right here, and that... Oh my gosh. No, we don't want plus... No, what are you talking about? No, we want... Oh, yeah. Let's test. What did we do wrong now? Oh, not 1 here, it's the index. Let's cut our string down to just 1 word. And then that's just 3 letters, so let's cut our test down here. Alright, so we're getting 19, 7, and 4, and it should be 28 and 5. So what's our issue? We have our alphabet. We're lowercasing, we're replacing. That's fine. That's works out good. We have our empty string. We let our incrementer equal 0, while our incrementer is less than text.length, less than or equal to I++. Position string plus equals alphabet, index of the letter that we're looking at. Did we mess up our alphabet? We messed up our alphabet. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Let's log alphabet.length. Oh my god. 26, so that's not the issue. Let's log text at index THE. Let's log alphabet index of text at index 19, 7, and 4. It's saying this should be 28 and 5. We're a number down. Are we missing something in the instructions? In this kata, you can see I have past solution too. So if we really, in this kata, you're required to given a string, replace every letter with its position in the alphabet. If anything in the text isn't a letter, ignore it and don't return it. A equals 1, not 0. That's what it is. Okay, so we're going 0 based. So, so what do we need to do? This needs to be, it should, +1 should work. Oh, right, okay, cool. So so an array normally starts at 0. They wanted our first letter to equal 1, so that was our issue. Cool. So now this will work. Let's chunk it in. Let's test it. Hey, let's attempt. Very cool. We did it, guys and girls. Cool. So let's go ahead and submit it, see how other people did it. They took tests. They said to uppercase. They removed everything that wasn't a letter. They mapped over that. They took the letter, the character code at -64, and then they joined it back together. So everybody's using the character code. Interesting. Alright, I think that's going to do it for today. My name is Patrick Hufflin. I am looking for a job in the Houston, Texas area, or in Texas in general. Hope everybody has a great day. Peace.